Theorems about the roots of polynomial equations. At the end of this video, you should be able to use the rational root theorem or the conjugate root theorem to explain different things about the roots of polynomial functions. This helps when you cannot factor a function. The rational root theorem. This is actually a pretty simple theorem, but it looks very complicated when you read it. All it does is give you a list of rational numbers that are the possible zeros of a function. It does not give you any imaginary zeros or any irrational zeros, just rational zeros. Now, not every number on the list is an actual zero, but it's the possible rational numbers that are zeros. And then from that list, you can eliminate some and actually find the actual zeros if you want to, or need to. Here is the rational root theorem. If you have a function that's a polynomial and has an integer coefficient and p divided by q is a rational zero, then p is a factor of the constant term a sub 0 and q is a factor of the leading coefficient a sub n. Just copy this in your notes and we're going to use it. Here's an example. List all the zeros of f of x equals 15x cubed plus 14x squared minus 3x minus 2. Now, all we're going to look at are the leading coefficient and the constant number, 15 and negative 2. And from those two numbers, we're just going to list all the possible or all the factors of those two numbers. For negative 2, you have 1 and 2 and negative 1 and negative 2. For 15, there's 1, 3, 5, 15, also negative 1, negative 3, negative 5, and negative 15. Then we're just going to use those two lists of numbers to find our answer. Basically, it turns into a fraction. All the different possible factors of negative 2 divided by all the different possible factors of 15. And you just make that big list of numbers. Those are the possible rational roots of this function. So here we go. The factors of negative 2 divided by all the possible factors of 15. So you have positive 1 divided by 1, negative 1 divided by 1, positive 2 divided by 1, negative 2 divided by 1. Then the next denominator, 1 divided by 3, negative 1 divided by 3, 2 divided by 3, negative 2 divided by 3. Then 1 divided by 5, negative 1 divided by 5, 2 divided by 5, negative 2 divided by 5. And then the last grouping, 1 divided by 15, negative 1 divided by 15, 2 divided by 15, and negative 2 divided by 15. This gives you what appears to be 8 numbers, but since it's plus or minus, there are 16 possible zeros of that function. So here's that theorem again, copied in your notes, but that's how you use it. Just make that fraction all the possible factors of the constant divided by all the possible factors of the leading coefficient. Whew, that one's done. Descartes' rule of signs. Another, when you read it out of the book, complex looking rule. Not necessarily a theorem, but a rule. All this tells you are how many possible positive roots are there and how many possible negative roots are there. So it helps determine the plus or minus. Here is the rule. Go ahead and copy it down, then we'll work out an example. It's actually pretty simple. You look at f of x, sign changes, and f of negative x, the number of sign changes. So here's an example. How many possible positive and how many possible negative zeros are there for this function? Well, first count the sign changes. Everything's positive. X cubed plus 2x squared plus 5x plus 4. Everything's a plus. So So there are 0 sign changes, which tells you there are 0 positive roots. If there were 2 sign changes, there would be 2 possible positive roots, or 0. So it's always whatever number of sign changes there are, or go down by 2. Now, for negatives, you have to do f of negative x. So everywhere there's an x, you plug in negative x. But be careful, you see down at the bottom, we put negative x in parentheses. What is negative x cubed? Well, it's negative x cubed. What is 2 times negative x in parentheses squared? Was 2 positive 2x squared, because negative x times negative x is positive. 5 times negative x is negative 5x. Now when you get here, how many sign changes are there? There's 3. So there are 3 negative roots, or go down by 2, 1 negative root. So it's either 3 or 1. There's no other option. Conjugate root theorem, the last theorem. This just helps you find other roots if you know one imaginary root or one irrational root. This is also very simple. If 5, 2 minus 3i, and 1 plus the square root of 2 are some of the roots of a quintic polynomial, what are the other roots? Well, quintic means 5th power, so there should be 5 roots. All that theorem said is if 2 minus 3i is a root, then 2 plus 3i is also 1. Also, for the irrational numbers, if 2 plus the square root of 2 is a root, then 2 minus the square root of 2 is also a root. And that all comes from the quadratic equation with the plus or minus the square root. That's where if 1 plus the square root of 2 is an answer, 1 minus the square root of 2 must be an answer.